In example 5.1b, we have a different equation, y equals 3 divided by x minus 4. So it's very similar to what we saw in part A, but instead of multiplying with 3, we're going to be dividing with 3 here. So starting again with x, which is going to represent a domain value, I start with subtracting 4, which by itself is not a problem. I can subtract 4 from any real number, but whatever I calculate here is going to end up being the divisor for 3. Now the only thing that I don't want to see happen is I don't want to see this denominator become 0. I do not want it to be 0. So if we were to set it equal to 0, like we did in section 1, take x minus 4, set it equal to 0, I would eventually get that x is equal to 4. And that is the number that we don't want to see. So the domain is going to be as follows. The domain will be negative infinity to 4, union 4 to infinity, and this is what's going to map to real numbers given by the equation f of x equals 3 divided by x minus 4. So the idea here is that this little calculation allows us to eventually be able to write this domain statement. And if you struggle going straight from the algebra that we did here to the interval notation, then you need to go back and look in section 1 where we use the number line as a way, as kind of an intermediate way, intermediary there, graphical representation to then get us to the interval notation there. That's how that's done. So at this point in the semester, we're going to be going a little bit faster with the domain calculation and not showing all those details every time, just writing it out and then getting the function definition.